Unit 2, Lesson 4. Today is all about constant of proportionality, which is the K, and equation from tables. So let's take a look at our essential question. What does K stand for? Now you probably already know from Lesson 2 in this unit, and this is a bit of a review, but we're going to go a little bit farther, make sure you understand what K is and how to find it. So proportional or non-proportional. This is the first time you have seen something that says non-proportional. So we're going to find the differences between what proportional is and what proportional is not. So here are some steps to guide you through that. What makes a relationship proportional? So these three things here makes them proportional. First, check all, and I have it in red and I have it underlined so you can make a big deal about the word all. Check all the ratios for K, also known as the COP. Do you remember what COP stands for? It stands for the constant of proportionality. You've heard it many times already. Hopefully it is sinking in. Number 2, if all, again in red, underlined, if all are equivalent, then it is a proportional relationship. Okay, so the first one was check all the ratios, all ratios. And if all of them are equivalent, then it is a proportional relationship. And then finally, number 3, if one or more of the ratios is not equal, then it's a non-proportional relationship. Okay, it's that simple. It's just math, and so you know how to do this. You've seen this already a bunch of times. The y is on top, and it's being divided by x. It looks like a fraction because it is a fraction, and this fraction bar means to divide, so that's y divided by x. In your tables, it's usually set up that x is on the left and y is on the right. Okay, so x is on the left and y is on the right. So let's go ahead and work our way through this, putting the y on top. 9 goes on top, x goes on the bottom, and 9 divided by 3 is 3. So what we're looking for 3's in all the rest of these boxes. So the next one is 12 is the y, goes on top, x goes on the bottom. 12 divided by 4 is 3 again. 15 goes on top, it's the y. 5 goes on the bottom, it's the x. 15 divided by 5 is 3 again. And finally 18 on top and 6 on the bottom. 18 divided by 6 is 3 again. And you can see that they are all 3's. They all equal the same thing. The ratios all equal the same. And so that means that this is a proportional, so we're going to call it a pro, for proportional relationship. And that's how easy it is. It's just checking the numbers, moving down, and getting through it. Okay, let's try the next one. It's the same exact thing. The very first one is the same as the first one, so it's 9 divided by 3 is 3. The next one is 16 divided by 4 is 4. So right away I can stop. I don't even have to go any farther and figure out any of these other ones because all of it's asking is it a proportional relationship or is it non-pro? So because this 4 is different than the 3, it is automatically a non-proportional relationship. But let's go ahead and finish this out. 25 divided by 5 is 5, and 36 divided by 6 is 6. Those happen to be all different. Okay, the third one. Going into decimals here, this is 6 and 6/10. So we carefully write it down with the decimal in the correct spot. Calculators would be helpful in this one. This one is going to be 2 and 2/10. Really tight in the boxes, so write small. You want to erase it, clean it up, or you can stretch it into this box. 8 and 8/10 divided by 4 is 2 and 2/10. Again, with your calculator. 11 divided by 5 on your calculator is 2 and 2/10 again. And 13 and 2 divided by 6 on your calculator, type it in, and it is 2 and 2/10 again. So you can see that they are all the same ratio, and if they are all the same ratio, then it is a proportional relationship. Proportional. And the last one, put the y on top. 36 divided by 3 is 12. 48 divided by 4 on the calculator is 12 again. 65 divided by 5 on a calculator, is 13. And 72 divided by 6 on your calculator is 12. Now, it was looking good because we had 3 12s, but because of this one, it's a different answer, a different ratio. It is not a proportional relationship. So this is a non-proportional relationship, non-pro. And that's how you check. Okay, we used the first thing, number 1, check all ratios. We did y divided by x for every one. And then we made sure that all are equivalent. And if they weren't, then it is not proportional. And so we had 2 non-pros and 2 pros. All right, we have some more here to work through together. So go ahead and start on the first one. And these boxes are getting tighter, so put the y on top, 2 and 52/100 divided by 4 and 2/10. And your calculator for sure is 6/10. 3 and 172,000 divided by 5 and 2/10 is 61/100. So that is the indicator right here. Already it's different, so we know it's going to be a non-pro. Let's finish out the work here. 3 and 72/100 divided by 6 and 2/10 is 6/10. And the last one, 5 and 612,000 divided by 9 and 2/10 is 61/100. So you can see we have some that are not equal. So that's a non-proportional relationship. All right, moving on to the middle one of the second row. The y is here. It doesn't matter that the y is smaller than the x. The y always goes on top, no matter what. So it's 3 divided by 9. And that can be simplified. 3 goes into both. 1/3 times. Okay, let's do the next one. 4 divided by 12. 4 goes into both. And that's going to be 1. 12 divided by 4 is 3. Okay, we have 1/3 again. 5/15. Divide by 5/5 to simplify it. 1/3. And then finally 6/18. And 6 can go into both of these. 6 goes into 6 once, and 6 goes into 18 3 times. And since they are all 1/3, the ratios are all 1/3 when they simplify, it is a proportional relationship. And our last practice one together, 18, or y's always go on top. 18 on top divided by 9 is 2. Nice and simple. And we're going to go down to 24 divided by 12 is 2. 36 divided by 18 is 2, and 52 divided by 24 on my calculator is almost 2. It's 2 and 1, and then the 6 keeps on repeating forever. So we're going to call this 2 and 16 hundredths repeating. So this is different than the rest of the ratios, but this is a non-proportional relationship. So I think you got the idea. You take y, you divide it by x. You be very careful. You use your calculator, and they have to all match to be proportional. So we had the first one proportional, the third one, we had one down here. They're all 1/3 proportional, and all the rest had something different. They were not all equal. All right, let's go down here and talk about the k, which is a ratio of y over x. Let's get this inside our heads. K is a ratio of what? Y divided by x. Remember, it can be written like that, or it can be written like this, y divided by x. All right, so now that we know that k is a ratio of y over x, if y over x is k, see this right here, y over x is k, if that's the deal, then find y. Okay, so how do we do that? Well, we use your solving one-step equations with inverse operations method. All right, so that's something that you have been doing a lot of, and we're going to go ahead and figure this out. Okay, so on this one, let's do one in the margin over here first. Y over x is k. Now we know that's true, but it says then find y. We want to find y, so we're going to locate y. There it is. Remember how we used to do this? There's a 1 in front of it. There's a 1 there. And what's in front of the x? There's also a 1. So do the 1's really matter? 1 divided by 1 is 1. They don't really matter. But if you want to get y by itself and it's being divided by x, then the inverse of division, I hope you remember we've been doing it a lot, is to multiply by its reciprocal. We're trying to get rid of this right here. Well, what's the reciprocal of 1 over 1x? That would be 1x over 1. All right, so is this going to work out if we multiply all of this together? Well, the top one, 1x times 1 is x, and the bottom one is 1x, or sorry, 1 times 1x is x, and that looks like it's going to be x over x. Well, what's x divided by x? Doesn't matter what number it is, it's going to be 1. So y is going to be left by itself. Now that was pretty confusing, possibly. So what we're going to do here is clean it up. Y is being divided by x, so we're going to multiply by x on both sides. Do it to here, then you do it to here. That's the property of equality. Look at this. That is a 1. X divided by x is 1. And y divided by 1 is just y left alone by itself. And what's k times x? It is kx. And that's what we're getting at right here. All right. May have been a little bit confusing, but we have some good examples we're going to do together to get practice. Now, you don't see any y's here, and you don't see any x's on this part right here. So this is c over p is equal to k. It's still a ratio of k, so you know that y is actually, or sorry, you know that c is actually the y, and you know that p is actually the x. So c is the what? It's the y. So we're trying to find c. Well, c is right here. It's being divided by p, so let's write this problem down. C divided by p is k. If you want to know what c is, you got to get rid of dividing by p. So we are going to multiply by p on both sides. That gives this view that as a fraction. P divided by P is a giant 1. Use the sideways 1 to cross them out. And C is left by itself, and that's going to be equal to K times P, which is KP. So C equals KP. You know, letters might be confusing sometimes in math, but they sure are nice because you don't have to use a calculator ever. You just don't have to compute them. You just know what they do. So this one's find R. So we're looking for R here. That means it's being divided by G. So all we have to do is rewrite the problem. R divided by G is equal to COP. Now, what does COP stand for? It stands for K. All right, so let's not be bothered by that. And R divided by G, we're going to get rid of the dividing by G, so we're going to multiply by G on both sides. That's going to cancel this G out, and R is left by itself, and R is equal to COP times G. What is another name for COP? It is K. Times G is KG. R equals KG. Remember, when you see two letters next to each other, it means to multiply. Okay, this last one that does not say y over x, it says find A, and our A we know is our y because it's on top, and our B is our x because it's on the bottom. So let's rewrite this problem. A over B is equal to K. Okay, A is being divided by B, so we're going to do the inverse of that, which is to multiply by B on both sides. The B's are gone, and A is KB. So it doesn't really matter what letters are representing y and x. As you can see, the y is on top, and the x is on the bottom. All right, flipping your paper over, we've gotten to the you do section to make sure you know how to do this. All right, here we are. It says writing an equation from a proportional relationship, and this is a you do task. If you discover a proportional relationship, write an equation in the form of y equals kx. And we just learned how to do that, so let's go ahead and get started. So these are all vertical tables here, and we have x on the left and y on the right. And to find all of our ratios, all we have to do is do y divided by x. So 5 goes on top, divided by 1 is 5. So we're looking for all 5s here. 10 divided by 2 is 5. And 15 divided by 3 is 5. So we have all of them are 5s, and that means it is proportional. So we'll circle proportional down here. And what does 5 represent? It represents the COP, constant of proportionality. Listen to the words. Constant. It's always 5. COP is also known as our K factor. All right, what do we do with this last box here? Well, how do we get y? We used our K. 1 times 5 is 5. 2 times 5 is 10. 3 times 5 is 15. So x times 5 is 5x. We put the number in the front, our coefficient, and x next to it with no multiplication sign because it means to multiply. All right, so this tells us what to do here. Let's write our equation. So y, doesn't matter what our y is. What did we do to it? We took our k, our 5, and we times it to the x. And what did we get? We got the column. Okay, y equals 5x. Does that work? We'll put the 1 in here. Put the first thing, 1 right here. 5 times 1 is 5. Yes, y is 5. 2 times 5 is 10. Yes, y is 10. And so forth. So it works. This is a good one. and we are using y equals kx. You remember where we got that from? We took our y, our ratio, and we got our x. And we wanted to know what y is, so we multiplied both sides by an x. And those canceled out, and y is kx. All right, the middle one. Well, one of the middle ones. Okay, I did that one basically for you, so you're going to try this one. Go ahead and pause the video and try it out. You're looking to find out if it's proportional or if it's not. Pause now. Okay, we're back, and you did some work on your calculator, and you probably got 3 and 5/10, 3 and 5/10. You probably thought it was going very smoothly until you got to the third one, and you got 4. Well, because you got a 4 here, this is a non-proportional relationship. And because it's non-proportional, it has no k factor. There is no COP. And so you cannot do this box right here. There's no way to do it. It's empty, it remains empty. And to write an equation, you can't write an equation because you don't have a consistent k, because it's non-proportional. So there's no way to write an equation for a non-proportional relationship with y equals kx. Okay? So go ahead and pause the video and try another one. Pause now. All right, did you have success on this one? It is a proportional relationship. The ratios are all 5/10, and so we can use our equation y equals, replace the k with our COP, which is 5/10, so y equals 5/10 x. So in this last section right here, what goes in the box? Well, you take all of your x's and you multiply it by your k, your COP. So if you multiplied all of these by 0 and 5/10, do this one down here, 0 and 5/10, you would get 0 and 5/10 x. All right, one last one to go. Pause the video and try it out. Okay, we're back again, and this one had some mixed numbers, and so I had to change those mixed numbers into a fraction. You can see that 5 and a half. I multiply the bottom, and I add the top, and that's going to be 11 seconds right there. And down here, 8 and a half becomes 17 over 2, or 17 halves. Okay, and then this is complex fractions, which was in our last lesson, and 22 divided by 11 is over 2. So you keep the 22 over 1, and then reciprocate your fraction that you're being divided by, and use multiplication, just like elementary school, KFC or KCF. Same thing down here, and they all come out to 4. And so since they are all 4, it is a proportional relationship, and 4 is your k, so y equals 4x. Now, if you're getting your math wrong on this, go ahead and erase it and make sure you're getting it right. We've had a lot of examples already about proportional and non-proportional and how to write an equation. And so we want to make sure that you have that down. If you don't, you'll want to rewind and then pay closer attention. Maybe you've caught yourself just copying the notes and not actually learning. You can also ask your teachers, but it is important to do this so that you know how to handle it when you get to your test, which is coming up real soon. All right, this next one is writing an equation from a proportional relationships. And so again, we have our x and our y, and this is a you-do section, so we're going to make sure that you guys get this down. Let me show you on this top one. You have x and y, which you are completely familiar with, another vertical table. And on this first section, what you want to do is, because you have a y and x, you're going to kind of work backwards on this one. I think we're going to turn around and work with y. I think we're going to do this. Y over x is equal to k. So just turn that around. Y over x is k if it's not that way already. All right, so we're going to take our 34 and 8/10 and divide it by 87 on our calculators. And we're going to get 4/10. Now that's our k right here. So 0 and 4/10. All right, and so now we're going to go with this next one, 3 and 6/10 divided by 9 is 0 and 4/10 again. Keep on going, 9 and 6/10 divided by 24 is 0 and 4/10 again. And the last one, 6 and 4/10 divided by 16. And your calculator is 0 and 4/10 again. So look at that. They all have the same number. So 0 and 4/10, 0 and 4/10, and 0 and 4/10. So that's our k. We know it to be true because they are all the same. That's good. So it is a proportional relationship. And down here, this is y equals kx. This is kind of a little bit redundant, but we're going to shift this around as well. Let's move the kx in the front. No. Let's leave it right there. Okay, so we're going to put an equal sign about right here, and we're going to put a parentheses for the k and a parentheses for the x, because what's happening between the k and the x? They are multiplying. So make all of these shapes, these symbols, all the way down. And what goes in the first one, k's, so we know that 0 and 4/10 goes in all of these. We're just substituting the substituting property of equality, so there it is. Okay, and then the x goes on the next one. Well, what's our x's? That's way in the front. 87, 9, 24, and 16. So 87, 9, 24, and 16. All right, so when you multiply all these, 4/10 times 87 in your calculator, you're going to get 34 and 8/10. The next one, one's going to be 3 and 6/10, 9 and 6/10, and 6 and 4/10. Where are these? What are these numbers? These are the y's. So it's just another way to see how this comes out. Okay, I'm going to pause the video. I'm going to have you do all of these. Let's change this one around if it's not already. C over B is equal to K. So C over B is equal to K. Now the X's and Y's have disappeared, but we know that the bags are going to be our X's and the candy is going to be our Y's. Okay, so pause the video and fill in this whole chart, and it all should work out nicely. Pause now. All right, you can see here it's all filled in, the bags and the candy. The bags are the independent variable, X or B, and the candy is the dependent. So it depends. If you want to know how much candy you have to know how many bags you have. Then you just multiply them, and you get your candy count. Now our K is 41, and that just means that there are 41 pieces of candy in each bag. All right, it's time to do the test readiness check. Now this one says all but one. Now pay attention to that very closely. All but one table is proportional. So all of them but one. So that just means there's one of these tables that is not a proportional relationship. Fill in the missing values for each proportional relationship, then find K. So you got to find K after you fill them in, and then after you find K, supposed to write an equation. Now this only works to find k and writing an equation if the relationship is proportional. And remember, one of these tables is not proportional. So go ahead and pause the video and try it out now. Okay, I did say to complete them all, but I do want to come back and just show you the first one. There was only one row that I could find the k factor, and that's the 3 and 45, because that's the only row that had the two numbers. So I did y divided by x and got 15. I knew that 15 was my k, and so this was definitely going to be a proportional, because all I had to do is fill in the missing boxes by multiplying the x by 15 or dividing by the y by 15. So there you go, it's y equals 15x. So go back to it, your last three. Okay, we are back now, and the last three are filled in. The second one happened to be a non-proportional relationship because look, 18 divided by 2 is 9, and 56 divided by 7 is 8. So that's a non-pro. So that's the one that you could not do an equation for. So there's no way here. No way for a proportional relationship. Okay, this next one, the third one, a little trickier. This bottom one was x was 18 and y is 6. So 6 is on top. 6 divided by 18 can be simplified down to 1/3. And since there was only one right here, we knew that the k had to be 1/3. So we wrote our equation, y equals 1/3 x. All right, now we took our x values and multiplied it by 1/3, and that worked out to get 6. So 12 times 1/3 is 12 over 3, which is 4. And the y ones we had to divide by 1/3. Well, that takes a little bit of 4th grade, 5th grade, keep, flip, change type style of fraction. So flip it over and multiply, and your x's are 9/5 and 6. And your last one, we had two of these. So both of them were 5 and 5/10. So that was our k factor, 5 and 5/10 x. And then we went through and finished it off. So if you got any of these wrong or you're confused by them, please ask those questions, because these are the type of problems you'll be getting on your test.